But yeah, that's just something to argue with. And I know people disagree. Well, you could always just have a third state where you have like this, not like a union of all three options. Don't you know this? And it'd be easier. I'm like, we're using C. Not everything has to be solved in the type system.
Yep.
We don't really have much of a type system in C, man. So
for some reason, when you build are starting to mock, like the mock language, like it's incredibly funny. Like I'm all ears. Like if you're doing like it's like oh.
No, it's problem is I've spent enough reading comments on the internet to go like I can always predict what they're going to say, and then they're going to tell me I'm wrong, and it's like fine, whatever, sure, go ahead, great, fine. I've read it all before, and it's not like I've not heard these arguments before.
Okay.
Yeah.
Some alignment on this part, and some like
Yeah,
okay, 90% alignment. Yeah.
90. Yeah.
Yeah.
Okay. C, lack of build system. Yay or nay?
It does have lack of one. That is correct.
What? What?
Yes, it does lack
Like,
a
is it
build
good
system.
or
That is
bad? Is that
correct.
But is it what's your take on this? Is it good or bad thing?
I think if you solve the textual inclusion problem, you'd probably fix this. Like, I don't know if you really want complicated build stuff in the language. Like, I don't think it should be I don't know what people are doing that makes their build so complicated exactly. I mean, I know obviously if I'm picturing like, you know, Fortnite or whatever, it's like, okay, like people go nuts in huge corporations, but it's, or, you know, just massive organizations doing really complicated projects. I understand why it gets more complex there. But in like the vast majority of code bases you actually look at, people are like massively over engineering this problem. Like pretty much just full stop. And so I'm like, I don't know how much you actually need there. I don't know.
I would split this up to three different aspects of the build system here. So the first one was the textual inclusion thing, and because C is in order with its declarations, that's why you kind of need header files, because you need to pre-declare things before you can use them.
Yeah.
So that's why header files kind of come about. And also, if you want to reuse things, you have using like multiple translation units in your build system, because C doesn't really define anything in that regard. Then yeah, that's why you need the header files. They're kind of consequence of that aspect. But I'm trying to think of another way of phrasing this one. So that's one aspect, is all the header file stuff, but it's also people like organizing things like taxonomies, and they don't really need to. People are afraid of like, well, my file is more than 100 lines long. I need to make another file now. And then they're not thinking about the cost of like how slow it is to open and read a file. And then also textually include that everywhere and then add it to the linker. Like that's a really thing. You know, if you look at the Odin code base, we regularly have 10,000 lines in a single file. And is that hard to deal with? The answer is no.
Yeah.
And you go, of course it's hard. I'm really struggling even with 100. And it's like, I don't mind the code bases I'm even in, because I always just kind of like searching around the code, jumping to the next like functions everywhere. And it's fine to read. I can just read from top down and it's okay. Putting it across files does not make it easier to organize or read. It doesn't. In fact, it probably makes it harder now because it's spread across multiple different things. And my text editor's not that clever sometimes.
Yeah.
So you think it might be better for your taxonomization problem. That's the second aspect. The third aspect I wanted to talk about was actually like the adding of linking. So some extensions to C have something called pragma comment lib, where you can specify in the source code itself what you're linking against.
Mm-hmm.
Now, I took this idea in Odin and literally went, actually, I want to codify this correctly, so it's not just like thing, and not just that, it also associates what it's linking against with like the procedures and the variables that you're linked against. So if you don't use any of them, they don't get linked against. Well, that lot. So that's the other case of the build system is, like when I was designing Odin, I was trying to get rid of the need for an external build system entirely. So you can just go Odin build dot, and it does all of your code done, right? Because you've specified the linking parameters in the source code itself.
Yeah.
And if you're keeping it external, that's when you get these complicated build systems, because it's all going to be different. But keeping it in the code is easier to maintain, easy to do, because it's got a standard. The problem is that this is going to be a problem with advertising Odin. So always people ask, oh, what's Odin's build system? I said, we don't need one. That's really bad advertising, because it says, what's the build system? We need a good build system. I'm like, no, we don't need one. And it literally goes over people's heads. Like, what do you mean you don't need one? So it's, you're not doing anything complicated. And I went, no. It's in the language. No. It's like, oh, for goodness sake. So you can't always, this is the thing is about marketing is like, we don't need one because we've just done the thing.
Yeah.
You should say you have one.
No, but it's like, we do have one, but they said, okay, where is it? And I'm like, no, they get confused.
Okay.
So I'm like, but that's what you do in C, because you can do that in some extensions of C. You can just do the pragma, but it's not as fancy as Odin's approach, by the way. It just links always, regardless of if you never needed it or not. But yeah, you got those three aspects to deal with, and you could improve it in C, obviously, if you were making this new C extension, because it's technically adding a feature.
Mm-hmm.
But I don't think it would work. There's so many different. It's CC, because you'd need to fix loads of things. You have to get rid of you have to have some form of out of order declarations to get rid of the header files. You would need to get rid of the textual inclusion, and also you'd have to specify in the linking stuff in the language, so you don't have linker as technically a separate stage explicitly anymore.
Mm-hmm.
But then you got a new language, and that's why I made Odin.
Yep.
Okay. Now, on this question, there was agreement,
Yes.
Yeah.
unfortunately.
Unfortunately for
Sorry.
you, yes. There's no. Come on, Jerry. You're not even getting this reference, Wukash.
Okay. We talked about build system or lack thereof, features to remove or to add. I want to ask about your opinion on C macros.
Mhm.
Ryan, we already learned that you like macros to some extent, at least for the for loop tricks.
Yeah.
Now,
well,
what's your
also I do
opinion?
it for so one thing that Bill brought up of like that he does from C++ is default values. I also use macros for that, just to be, so that's another one of those fancier macro trick. Like I've got a function, I define the function I want, it takes a pointer to a struct. I'll wrap that in a macro. The macro takes variadic arguments that I use to initialize the struct itself. So then you can call a function and say, there's a bunch of default parameters, and then you can also say like, oh, like dot foo equals 5, dot bar equals 6 in the function parameters themselves. So you can do that with macros. My opinion on macros is that I think that they're probably one of the only reasons why C has survived, like to the degree that it has, because people can shape it into whatever they really want it to be in a lot of ways. Because the base language itself is just kind of not as expressive as you'd want for a number of problems. And so having a very simple like replacement system, simple, you might you might pick bones with, but it's but having some kind of replacement system is good. I'm not sure that if you designed it from first principles, you'd make it a textual replacement system. That seems like probably not the correct. If you wanted really good macros, I'm not sure you'd go to textual replacement.
You do hygienic macros like every other language does.
Yeah.
If you want macros, that's what you do. But
Yeah.
Can you say hygienic macros? Can we interject?
hygienic macros.
Yes. Can we explain that?
So explain textual macros, which is how C works. They literally just replace the text that like in the code. Hygienic replaces the AST. So it's kind of a lot much safer in that regard.
Mm-hmm.
And it doesn't really change the text. Now, the thing is, C macros, and yeah, I know it's not my turn now, but I'm taking the turn. Screw it. This question.
No, we need to come back to Ryan.
No, we'll come back. But it's still the same. It's still the same thing. But like they need to exist. Like the macros are there to extend the language when you find something lacking in the language. And it's first thing, obvious thing for macros are clearly for even include is a macro. The conditional compilation is one. And then also adding language constructs which are missing, which is kind of like what Ryan's doing with a lot of his stuff. And that is what they are. To me, macros are the need for a macro is usually a sign of a missing language feature or a language construct, usually. Not always. I can think of, again, the exceptions where it's not the case. Like I'd say conditional compilation isn't necessarily it's fine in the macro system, at least in C. But the rest, I think it's just, it means there's something lacking in the language, which is why Odin doesn't have like macros when I designed it. Because I kept thinking I was going to need some sort of like, not in say macros, but something like that to achieve the goals. And every time I came across it, I went, no, there's a better way of solving this. Oh, there's a better way of solving this. Just add that feature directly, which I was mimicking with a macro. But yeah, so they're needed for C. Again, C without its preprocessor wouldn't be C, because we're not talking about, no one ever thinks of C without the preprocessor.
Yeah.
Try write C without a preprocessor and you won't get far.
Yeah. I think there's also, on that point, there's a distinction here between whether or not you're building like core ecosystem building blocks versus whether or not you're building a kind of the best you're putting in lots of engineering resources to build the best programming environment for you personally. So in the case of Odin, it makes perfect sense that he would add these features to Odin itself, because they provide the needs he was missing from the base language itself. In the case of C, when it's like supposed to be this like lingua franca, like, oh, this is a ton of code is written in this, it's spreading far across the ecosystem. Ideally, the kernel of it is actually relatively small and constrained. I mean, it's not, but it's more so than something like C++, right? So it's better in that regard. And I think if you're doing that, you need some kind of macro system so that you don't end up having an ever-growing spec for arbitrary future uses of the language, right? If you're building like, okay, I'm going to sit down and build the best thing for me to program, then you don't need macros, because you can just go and change the actual code. Like you can go change the tools that you're actually building. If you're trying to build something that's going to last for like decades and decades, you don't really want to be in a situation where you have to keep revisiting the spec, and you have like all these different compiler implementations. You have there's all these like competing interests over the language itself, because it's like this widely distributed thing. I don't think for that situation, it makes less sense to try to solve missing language problems via changing the language spec, because it works much less good when it's not this like centralized, oh, I'm the designer of this tool, I'm going to do exactly what I need to solve this problem. And so I think long way of saying I agree with Bill, I guess, that it's like, no, C needs them.
C needs them, but I'm going to make a caveat on here as well. C needs them, and they're necessary for what it's doing. However, my point here was about this Odin thing, was I think it's a lack of a feature. If you have a language which has a lot of macros ability to it, like the good example of this is Common Lisp.
Yep.
And there's something called the curse of Common Lisp, which is where, because of how simple of a language is, and you have these basic, the ability to do all the macros, each person who makes their own macro set is now incompatible with anybody else's piece of code, because there's no idioms, common shared idioms anywhere within your stuff. So if you, like Odin, we have a lot of things built into language because we're effectively encoding conventions and these idioms in the language that everybody else can then use. Now, weirdly, C does have some problems when it does all of its macro stuff, right? People have like incompatible conventions, even just incompatible like namespace collisions and such, because again, it's not hygienic, it's one giant namespace. Mm-hmm. But for some bizarre reason, C hasn't actually suffered from the curse of Common Lisp as much as you'd expect it should do. Mm-hmm. And that is actually surprising to me. But it might not be, I think it probably is just because of what the nature of C is, rather than say the nature of Lisp, or Common Lisp. So it's weird. Like there's some just historical things, and it'd be nice to actually just research more of the history of this, like the psychological reasons why people do certain things in different languages. But this is one of those where I've not researched much on, and I'm like, why has this not happened as much as it did? Or maybe it did. It's just that people who use C hit it quicker, like the curse, and they went, oh, we just need to stop doing this.
Yeah, my intuition, I mean, I'd probably go further in the direction of hitting the curse than most C programmers, just because I've got like metaprogram files that are not C at all, and so that gets further in that direction. I think that my intuition would suggest that it has to do with the fact that there is there's a significant portion of the base language that is concrete. Like it's you see this everywhere in programming discussions. People really want to go to extreme directions. Like they're like, logically, like if you have a macro system, it should lead, if you take that to the limit, it should lead you to the curse of Lisp. But it's like, we're humans, we're not operating at the limit, we're operating within the bounds of psychology. So the fact that there is a concrete language and then there's some ways to spiral off of it, I think keeps C much more grounded than something like Common Lisp.
Yeah.
So that's my intuition. Obviously I haven't researched it or anything, but that's how it seems.
No, it's one of those because it's not. I could just go. I do try and research a lot about psychology of different people's languages because that's how I approach language design in general. It's a psychological perspective, not really like a type theory perspective. Even though I know the type theory stuff, it's just it doesn't need to help me that much. But it is interesting. Like, why did C not spiral off as badly? But the problem is, it probably did. But we haven't seen it as much.
Yeah.
Well, can you elaborate on the psychology of the languages a little bit more? Because I have no clue.
What I mean by that, is how people think about a language and how they use that because of how their mental models compared to the actual like rules of the language. Like again, as I explained to you earlier about was like C's declaration syntax. Most people, when they learn C, don't actually understand how that works. They've got a basic mental model of how it works, which is wrong. Like it's always wrong until they actually learn it. And then they go, wow, I understand it now. This is retarded. But it is that is kind of the thing is they have this mental model about how they approach things. So this is how I've always approached Odin is very much how do I think people are actually going to interact with it? And also how do I see them interact with it? And then I ask them effectively through certain questions, never directly, because if you ask them directly, they don't answer correctly. You have to ask them certain other questions to get the answer that you want. To find out what was your mental model, what were you actually expecting, what were your intuitions here? Because then you'll find out that these intuitions that people have are really complicated. They're not simple. Like they've got a load of assumptions. They're not an instincts going in there. And you go, oh, that's why you're assuming this should work, but it doesn't work this way. Like there's loads of things in Odin which are very ergonomic to make it those intuitions, but there's loads of places where it gets against their intuitions. And usually in those cases, I've done it by design. Like, no, it's on purpose that there's some friction here. But it's like the same thing with C. It's like, why are people using the way they use macros? Is it just conventions that kind of people have got stuck to, or is it just naturally that's how people think? And that I think that's a much better way of like approaching language design rather than thinking about the proper type theory, because people don't use type systems the way you would hope they do. They really don't. And usually they need to circumvent them as well. So when they do circumvent them and they've spoilt all your amazingness of like, but this was meant to be perfect. And it's like, welcome to humans.
All right. This was what the C macros. Yes.
Okay. C macros. Yeah.
Now we're moving on to the next large topic. And I think, Bill is first now.
Yeah.
Okay. Are you ready?
Okay, go ahead.
Undefined behavior.
Oh, I'm first. I'm sorry. This is my rant topic normally. You've probably seen me on the internet ranting about this before.
Yeah. But also paint a picture for everybody who is listening. What is it like? What's the deal?
Oh, okay. So the first, I'm going to phrase it as UB specifically, because that's how most people call it. And that UB is in itself undefined what it means. It's a bit of a joke. So when you read the C specification, right, there are things in the specification that they specify. There's also things that they specify, they state that cannot be specified, right? So this is undefined behavior. There's also things in the C specification which they call undefined behavior, but it's not that they haven't defined it. It's more that they can't observe it. So I would class this as unobservable behavior, right? So a good example of unobservable behavior for people who don't know is anytime you violate the memory model in C, the compiler assumes you're adhering to it. So therefore it cannot observe your violations. So therefore, however it optimizes or deals around it is now unobserved and thus undefined. That's one aspect. Now, the problem is a lot of the things in C which are undefined are trivially definable, like extremely so. And they should just define most of it. Now, the argument, the problem people are going to batter at me is that there's two sets of things. Well, the C specification can't define everything. And I'm like, you're correct, because there's different platforms. But you should have these, we've always said, you have these mini specs where they're platform specific. So now you've got platform defined behavior. And now people say that's still UB. And I'm like, no, it's defined for that platform. right? Yes, that is maybe undefined across all the different platforms. No, it just means you just have to define where you're defining it. Is it defined in the spec, the compiler, the platform, or the library code? Define where it is. Right? There's a bunch of things you could just define and define how that behavior is. That's the first thing. Again, there's some things that cannot be defined. Like again, if you're violating the memory model in C, you can't actually define how that should happen. So in some cases, you just make some people redefine that. Some languages say this is a legal behavior, so they change the name of it. But in C, we say UB all the time. There's the other aspect where people say, don't you know, and this is actually one that really frustrates me enough. You can probably guess where I'm going, Ryan. When people go, we need undefined behavior to do optimizations.
What?
This is an oxymoron. Yeah, so they will make this argument, and it's a really common argument, and I know what they mean by it, but they don't. And they'll say, it's like, no, we need undefined behavior in order to optimize code. So the problem is again, they've merged these different concepts together, put them all in together, and I'm like, okay, great. If you're just talking about the memory model, the basic memory model, then yes, you need to make assumptions about people's code, right? You're defining how things work, right? So you can then optimize on it based on those assumptions. Now, if people violate that thing, yes, it is undefined, but that's not you relying on undefined behavior. You're actually relying on defined behavior to do optimizations. That's the first aspect. The other aspect of undefined behavior, which is what really pisses me off, sorry, my language, is where people say, yeah, but we like to be able to make arbitrary definitions. So we can say this is undefined, but so therefore we can do whatever we want here to then optimize. If you've got arbitrary rules, that's not optimization. That's garbage in equals garbage out. That's not optimization anymore. Optimizations require rules to follow in those guidelines.
Yep.
That's it. So this is why I've had this UB rant before numerous times. It's just, I get annoyed talking about it to people because I know I make distinctions, but they don't, and that's fine. That's not necessarily an issue, but it's just very much like, stop using this word, undefined behavior, because it's literally undefined in itself.
All right. Thank you for the rant.
There we go. Sorry, there you are. You're welcome.
That's good. Yep.
Now, Ryan, you obviously disagree with Bill here. So can you just say it out loud?
Obviously he does, yeah.
Obviously. No, I mean, I couldn't have said it any better. I think like one of the things that Bill was touching on is like, it kind of, I can call back to the concept that he brought up, which is de jure versus de facto. Everyone de facto is doing, it has to look to the platform, has to look for these things. Like they can't rely on just the C spec. And so all Bill is really saying is like, let's make the de jure, like what we actually write down, let's make that actually map to reality. Like, let's not have this like completely arbitrary external space where people are zeroing in on this like abstract language world that has nothing to do with what people are actually doing. Just actually write down what the rules are that you're following, that people actually follow, so that it's much easier to find this information. Like, because everyone has to write this way anyways. Nobody is writing just to the C spec. So, I don't know. I guess I'm sorry, Wukash, but I agree wholeheartedly with him. It's like, this is just not great situation. Really.
No, and I it's the other aspect where I'll get another pedantic thing I want to moan about again. Sorry, the rant. But the point is that a lot of people say, but we can't have these optimizations if you define this rule. I'm like, no, what you mean is you can't do these passes, right? They're not optimizations. Again, I know it sounds like I'm being a pedant with the words here, but I'm like, no, you were actually saying things just wrong.
Yeah.
Like, there are certain compiler passes you can do on your code, and they may be optimizations, they may be not.
Yeah.
Right? And said, but we can't do this anymore. I'm like, and?
Yeah. Yeah.
Okay.
Yeah. I think it's a symptom of a problem, which is that people are working on problems and they're really narrowed in on that. Like, they're like, we need to make these benchmarks better, and we can cause these passes to occur, which will make the benchmark numbers look better. But they have to like zoom out and think about what's the actual analysis of the situation. Like, who's using the compiler? What does their code look like? What do they assume their code to what do they assume their code to actually be turned into? What do they assume that the compiler will generate? And are you violating that? And if the answer is yes, then that's a bad decision. You should not have done that. So the spec should address this and just define what it is people are actually meant to expect.
There's also another aspect I'd say, which is tooling. The compilers, if you want to say you've got illegal behavior, let's call it illegal behavior, just to make it more clearer, right? Well, why doesn't the compiler just tell you you're doing? Because a lot of those cases, it knows.
Yeah.
So, and I know it can't always figure out until it's got to the back end. You can't do it in the front end, and do it in the back end. But like, I would rather have this tooling to say, hey, you've made an error here. This is violating the rules. Stop in the name of the law, kind of thing from Oblivion. But like, and then just literally tell me, fix this, please. Just like fix.
Yeah.
All right. Undefined behavior topic is closed now. You can breathe, Bill. And we unfortunately found 0 disagreements. Very disappointing.
Yep.
Oh.
Yep. I'm sorry.
There are a couple of questions or like points, topics that we sort of covered already. So I'm gonna skip like include system versus modules and stuff like that.
Mm-hmm.
Other languages often come with either standard library or just generally speaking, a language with data structures, like a world full of data structures, hash maps and vector-like dynamic arrays and stuff like that. Now, everybody who programs C has their own like standard library layer with their own data structures, pretty much. Okay, is this a good thing or a bad thing? Now Ryan starts off.
Well, it depends on your priorities, I guess I would say. Like, do you want how much of like the code written in this language do you want to be sort of translatable? Like how to what degree do you want people to be able to agree because they use the toolchain? To what degree do you want them to have to agree on different data structures? The answer to that is probably not like 0. Like the fact that there's nothing in the standard library in C is probably not the optimal thing. Like they probably should have standardized like length-based strings. Like there are things that are very simple that you would probably do. Odin seems to follow this as well. Like instead of having operator overloading, it just has a map data structure, just has strings, it has these concrete concepts that you concretely know people need to use. I think a conservative approach like that is pretty reasonable. But on the other hand, I tend to take the concern of the cursive Lisp, if you will, a little bit less seriously than other people. So I'm okay with me having my own code base. Like I need my own code base anyways at some point. If it doesn't include certain data structures, that's great. At least if they're not assuming too much. Like if these are data structures that are very complicated, that are making very specific trade-off decisions that do not apply to my case, for example, I'm not sure what the utility of that would be. But so basically what I would say is that if you were to go back and design C from first principles, you would include more in the standard library than is in the C standard library for sure. But I don't think, but I think what people tend to want is the standard library should solve all their problems. And it's like, I'm sorry, but you still need a code base. So, and when you have long running code bases that exist for a very long period of time, you'll end up having one no matter what. And so I think that that's like a reasonable architecture actually for people to end up having. Not everything can be centralized in the language. But yeah, you would have more than C's standard library does. Like we've covered, the C standard library just kind of sucks. So
just to re-emphasize the point.
Yes, it's not great.
Bill,
if assuming it's proper C and we're not doing extensions like I said with slices, then yes, then you would have to have some nice data types. Like you'd have like a length-based string type would be good. Like just have that built in. But again, it's still going to be a bit finicky to use, but at least if it's standardized, it's nice. The thing about this just goes back to the idiom thing is in the case of Ryan, like say Ryan doesn't have that problem issue, but the thing is he's got a product rather than a library. Like you've got an entire self-contained thing, which doesn't need to, the rest of the world does not need to interact with, right?
Right.
But if you're making libraries for people, you need to interact with everybody. So you need some common conventions that people use. So if you actually had a built-in string type, an array, like let's say a slice type, and let's say a dynamic array as well, if you had all those built in and use those conventions, then it'd be great, wonderful. Like you've got the same like style across all of the things, which is helpful language. But C is this weird oddity where if even in how C works now, you're gonna get issues. Because again, it's you've got this generic dynamic array. It's like, you're right, but C doesn't have generics. So you could have this macro approach, but it's not going to work very nicely. And it's like, there's no nice way around this. Like, this is the point. Vanilla C is going to struggle. The best you're getting out of all of this is just a string type. That is pretty much the only like data structure that I would think could be there. Also, the other one I'd probably say that you could do in there is a generic linked list, it's kind of like the Linux kernel based linked list where you just have basic pointers for the things, and then you have to do the container of macro to get the actual like parent thing from. So that's about the only data structures I think would work in actual C that you could get. Everything else, you would have to extend C to do it to make it nice, unfortunately, if you're just talking about just data structures.
This is probably a point of disagreement, I would say, because I think that not to say it was intentional, but the conservative design of C's standard library having fewer standardized data structures, to me, pushes APIs to, it adds incentive pressure to APIs to be simpler with respect to what they're actually allocating and what types they're introducing into the system. So it's like, like C libraries, one of the properties you'll find more in C than in other languages is that people are writing APIs that are like, oh, we don't allocate it all for you. Like, you have to pass us the resources, you control all of that. We're just doing the simplest boiled down version of this transform that our library could provide for you. I think that that's a positive incentive to apply. So I think that the conservatism approach inside the standard library with respect to like introducing lots of standardized types that people standardize on, I think that's probably to some benefit. I agree with you on length-based strings, though. Like, that should be a thing. If you had a slices feature, that would be better. I'm not sure if I would want dynamic arrays standardized even, because again, that gets into allocations and things like this. But
no, this is where things get a bit weird. Yeah, because you got the problem is you'd have to have a standard allocator type as well.
Yeah.
And this is the problem. Like, I know this is probably where we slightly disagree, but we don't disagree. I think it's kind of a thing. Yeah, I'm trying to help you here, Lukash. But like Odin has like a built-in allocator type, right? Because this came from when I was writing my C code. I had my own allocator type and it worked quite well. The whole point of the allocator type is it's a generic way of doing like a general allocator, because I'd argue that most people don't need custom allocators either. And when they do, they kind of just want to have like, oh, I want a tracking allocator. So I just want to override the current heap allocator. Ryan, on the other hand, and technically myself, we just use arenas everywhere where we can. So we don't even need the allocator interface. We just have an arena interface, effectively, and we pass around arenas everywhere. However, the problem is, this is the problem with a language design, is most people don't do that style of allocations. So if people still default to the malloc freestyle approach, you need this generic interface that can allow you to swap that out. So in the core library, if you're on the library, for C, if you need to do allocations, you would have to have this general thing. However, if I was designing the C standard library, which is now going like, 5 questions back now, like I would just say, hey, there'll be some basic allocation things, effectively virtual memory, maybe a heap allocator, but it's not global. And then every other function you have, none of them ever allocate. They all just say, here's a buffer, you pass in the buffer. And that's it. Or if you pass nil to it, or null pointer or whatever it's called, it'll tell you how much to allocate, like Win32 APIs do, and then you can pass the buffer to it. So you have this pretty much nothing ever allocated. So you don't even need to worry about the allocator interface, which is the same with the dynamic array thing. You don't even need the dynamic array in the standard library, as if every API was designed that way, not to need it.
So this is why I think the arena would be a useful concept to standardize in the standard API, because the arena is a slightly more flexible version of a buffer where it's basically all pre-allocated for the most part. Like, you can configure it always to be pre-allocation, period. But the API of it allows for either chaining or contiguous growth, depending on how you want to set it up. And so it's basically like the simplest version of allocation that you could imagine having in an API. And so I think for that reason, it's a useful it's one useful building block on top of just a raw buffer that I think is, at least in designing code-based APIs, I've found to be extremely useful and widely applicable. So I think that that is a likely candidate. I mean, it's in my base layer. I think it's a likely candidate for the standard library because my base layers and my code bases, they're kind of what I would imagine would be in a standard library, if that makes sense. So yeah.
So again, mostly agreement, slight disagreement, but
You're happy there. We got a slight bit. I hope you're happy
honestly
with that.
not satisfying enough, But okay.
Yeah.
Okay, now I'm gonna skip most of my remaining questions. I'm gonna do the last one, but I'm gonna say in the meantime, I've been posting the Q&A link, and there are a couple of questions in there. So I didn't really review them, but let's go. We have like 20 minutes, so we're gonna have like last question from me,
Okay.
and then we're gonna do 1 or 2 questions, the most upvoted ones. So
Okay.
if you're in the chat and you want to see a question, there's now like question battle under the link I posted.
Oh, you got your
So-
disagreement.
What?
That is where the controversy for this episode was. It was in the comment section.
Yes, the comments are the ones that are disagreeing with us.
No,
Right.
no. The main point here is this disagreement between you. Like, that's the whole deal. Anyway, okay, last question from me. Okay, last question from me. Where would you learn C? Like, where would you go to learn C? Where would you learn it from? Today, 10 years after Handmade Hero, where would you learn it from?
So I can't say Handmade Hero.
You can.
Oh, I did. There you go. There's my answer.
All right.
I didn't learn C from Handmade Hero. I knew C before, but it was very much like that approach to writing C, I think, is still one of the better ones to learn from because all of the other resources out there are bad. Again, they're not bad. They're just teaching you like let's say the malloc-free approach if you do an allocation, right? Which is fine to know how other people do it, but it's not a good way of writing C. So it's kind of there's just not many good resources. This is half the problem. It's all in people's minds and brains and stuff.
So, Handmade Hero, are there any other? Or is it like desert out there?
I don't know.
Ryan.
Yeah, I'm once again sorry.
There is a blog, Digital Grove. Digital Grove.
I don't
think
teach. I
it
don't know if I
has
teach.
Couple of nice.
Yeah, it might teach you something. I don't know if it's going to teach you C programming. But I try to put out what the stuff that I feel like I've learned. But Handmade Hero is my answer. Sorry to agree with Bill again and everything with Cash.
Yeah, but we
but
feel
it's-
like that's where we sparked from anyway. That's how we know each other, obviously.
Yeah,
But it's
yeah.
also like, I don't know. This is the problem. Is I'm always bad at giving resources. When people say, well, what's a good book on X or Y and Z? I'm like, I don't know because that's not how I learned.
Yep.
And I can't tell you how I learned because it was all over the place.
Was it? How much was it from people at your like work or group or university? Like, how much from other people compared to how much from like books and resources?
I would say none from other people for me, unless you count Casey. Like, unless you, well, okay, no, not true. I had a big leap forward when I worked first in the 4-coder code base, and then I worked with Alan. I learned a lot about how to properly write C in that time period. That is probably the biggest leap forward I've had because I've worked with alongside other people. But the vast majority of people in college or workplaces, I don't think they're really writing the best C either, so it's not going to teach you very much for the most part. Like, Handmade Hero was a really unique thing because it's like Casey's such an excellent programmer and he's such an excellent communicator and you get to sit there and follow line by line as he explains and does all these things. And then at the end, like whenever you decide to stop, you've got a starting point for a project. That's a huge resource. Like there's just nothing really that beats it so far.
And he was asking the question about resources, or is it people resources? Technically, I would say resources because the people I've like in real life, I've not known many programmers in real life. Most of the program I did was always like solitary. And then when I did do programming either at, say, I did technically do programming at university, but it was a single course and I passed it with flying colors because I already knew how to program. It was not like this was an introduction for like physicists learning how to use MATLAB. And I think on that course I got 98 over 100. And the only reason I couldn't go 100 is they marked me down for not using enough comments. That was it.
And they were probably wrong about it.
It doesn't
That's
matter.
a badge of honor. Badge of honor.
It doesn't matter. They weren't going to give me 100. That wasn't the problem. But regardless of that, I think there are people I've learnt loads from, but it's a lot of it's come after Handmade Hero is the best way of putting it. But the people I've learnt from is just like reading their source code. Like one of my favorites to always point to is Sean Barrett. And again, this STB libraries. And again, I know you did the wonderful talk. It took me ages to watch that thing with Sean Barrett. But Sean Barrett is one of those other people I would say thank you a lot to. He actually is kind of my impetus for making Odin as well. Because one of his famous things was like, how does he program in C effectively? And what he kind of showed to me that most of these higher level languages just have better libraries pretty much. And it's not not languages per se. It's the ecosystem. It's the mountain, as we're calling it, that gets you off there. And once that clicked to me, I went, oh my goodness, he's right. And that actually tells me that, okay, all of this language things people are doing, they haven't actually done much. And C is still productive. Like, unironically, as long as you've got a really good core library for C, you can be stupidly productive in it. In fact, you can be more productive than some people using these higher level languages like Python or Ruby or whatever. And I remember that talk, and it was kind of part of the reason why I made Odin in the first place was because of it, which sounds about weird, like, oh, you can make C more productive. But it's like, no. I realized that, yes, I can get there, but I'm like, to get even more productive, then I'm going to have to start somewhere else and do it from there. So again, it's reading the code like STB library has been brilliant, and I learned loads from them, loads from Casey. But it's like, it's the code I've read from, and not necessarily books, like actual written books. None of them have been helpful to be really good at anything. Like at C, I mean specifically. It's just been reading loads of different bits of code from randomly on the internet. I'll be honest with you, and that's because I've lived my life on the internet. I'm of that generation. Like, I grew up on the internet. I still am. I don't know a time before the internet.
All right. Thank you so much for this round of questions. Now, a little bit of breathing room. We're going to head towards the community questions, and I have no idea what's in there, so it might be great.
No.